Hey guys, so here are the notes for 1.3. We're now going to go ahead and solve quadratic equations when our a value is just equal to 1 by factoring. Okay, let's go ahead and get started. Okay, some terms that we need to talk about are monomial, binomial, and trinomial. So what these mean, monomial means one term, binomial means two terms. And what do you guys think trinomial is going to be? Yes, that's going to be 3 terms. Okay? So you're going to hear me say those words quite a bit throughout. Definitely this unit when we're talking about quadratics. Okay, so we're going to first talk about to factor. So for example 1a, we have x squared minus 9x plus 20. So in order to factor, we are finding numbers that multiply to our last term, which is the constant, and add up to our middle term, which is the x term, okay? So let's figure out all the numbers that multiply to 20. We have 1 and 20, 2 and 10, and then 4 and 5. Now we need to see which pair will add up to our negative 9x. Well, that's going to be 4 and 5. So our next thing is we're going to create 2 sets of parentheses. X is going to be in both of them, and we have 4 and 5. Now, since we're adding up to a negative 9, we need to make sure that both of these are negative. So our factoring is x minus 4 times x minus 5. Okay, let's look at part B here. We have x squared plus 3x minus 12. We are going to do the same thing. We need to find numbers that multiply to 12. So we have 1 and 12, 2 and 6, 3 and 4. And we need to find a pair that will add up to 3. Well, actually, we look at any of these, none of these actually add up to a 3. So that means this is going to be non-factorable. Okay, let's talk about more or specific types of factoring. So these are special factoring patterns. The first one is what we call difference of two squares. So we have a squared minus b squared, okay? So when we factor that, that's going to be as a plus b times a minus b. Let me give you an example. So we have x squared minus 4. Notice we have a binomial, that means 2 terms. And this is called a difference because we are subtracting. And of 2 squares, because our a value is going to be a perfect square, in this case it's 1, and our last term, the constant, is also going to be a perfect square, which is 4. So when we factor this, we have 2 sets of parentheses, okay? So the square root of 1 is just 1, so we just have 1x and 1x. And the square root of 4 is 2. So we are going to have a plus 2 and a minus 2, okay? So make sure you definitely have the plus and minus. And of course, order doesn't matter. So you could have x minus 2 times x plus 2. It'll still work. Okay, the next one is what we call perfect square trinomial. Remember, trinomial means 3 terms. So we have 2 different ones. The first one is a squared plus 2ab plus b squared. And when we factor this, we can have a plus b squared. Okay, so let's have an example of that one. So we could have x squared plus 4x plus 4. So in order to factor this, we know numbers that multiply to 4 are going to be 1 and 4 and 2 and 2. But which pair will add up to that 4? It's going to be 2 and 2. So we can do x plus 2 times x plus 2. Now notice that the terms are exactly the same. The factors are exactly the same. So that's why we can write it as x plus 2 squared. So anytime that your factors are exactly the same, you can have that exponent. Now we can have the same thing where we have the minus, so a squared minus 2ab plus b squared, and how we'll factor that is a minus b squared. So I'm going to just use kind of the same example, but in this case, I'm going to have a minus 4x. So in order to add up to a negative 4, we will have to have x minus 2. And of course, since these are the same factors, we can rewrite this as x minus 2 squared. Okay? So now we're going to go ahead and do examples of these. So for example 2, we're going to factor our A, B, and C. So what I would like you guys to go ahead and do is pause the video and do A, B, and C. Okay, let's see what you got for the first one. So let's identify, is this going to be a difference of squares, or is this our perfect square trinomial? Well, notice we have a binomial, so 2 terms. We have subtraction, so that's a difference. And we have our A value, which is 1, and 49, and those are perfect squares. So this is going to be our difference of squares. Okay, so how we're going to factor this, we have 2 sets of parentheses. We got x and x, because the square root of 1 is just 1, so we have 1x and 1x. And what's the square root of 49? That's going to be 7. So remember, one of them has to be a plus, and one of them has to be a minus, okay? Let's look at part B. We have d squared plus 12d plus 36. Well, in this case, this is going to be our perfect square trinomial because we have 3 terms here. And notice that our middle term is a positive. So when we do this, we're going to have our, well, here we're going to have d's, just because that's our variable. And for 36 here, so remember, really you can think of what's the square root of 36, right? Because we want numbers, and then we have 4 and 9, and 6 and 6. Because which one's going to add up to our 12? It's going to be 6 and 6. So we are going to have to use the plus because in our original trinomial, we have an addition. So I have d plus 6, and that's going to be a squared. Okay, let's look at our last one here. So once again, notice this is going to be, again, a perfect square trinomial. And you're probably wondering, well, how can I recognize that? Well, notice that the constant is a perfect square. And whenever we think of the number that multiplies to it, if we multiply that by 2, it gives us our middle term here, okay? So I have negative for my middle term. So when I write this, I have z minus, and what's the square root of 169? That's going to be 13. So if we had 13 times 13, that gives us 169. If we do negative 13 minus 13, that gives us our negative 26 in the middle. So I have c minus 13 squared. Okay, make sure you watch the next part of the 1.3 notes. We are now going to solve these quadratic equations by factoring.